Hi, my name is Zico from Alpha10 Technology and welcome to our series of environment troubleshooting videos. In this series we'll be going through the environment system in a bit more detail to see how it works, and they'll be going through most of the problems that you might encounter with the environment system and how to troubleshoot them. So the first video that we'll start with today will be how the environment system works. This will help us in understanding and diagnosing most of the issues that you might encounter with the environment system, which we'll be covering in subsequent videos, like gaps in data, missing data, logger communication issues, incorrect readings, or software issues. So before I carry on with the video, just to say that we have timestamps in the description section below if you wanted to jump to the appropriate section. But if you're watching this video for the first time, I'd recommend watching it in its entirety. So let's get started. Okay, so let's start by taking an overview of how the environment system works. So the basic layout consists of a data logger with one or more converters connected and optionally alarm units. Now, the converters are the interfaces between your sensors and your data logger, and as the name implies, they convert the signal from the real world signal, like your temperature, your humidity, your current or whatever, into a digital signal which is then fed to your data logger. Now, they're connected to each other and to the data logger using a network cable, or as I prefer the name, converter cable. And as you can see at the back of each of these units, or on the data logger or the alarm unit, they each have two network ports, or as I call them, converter ports. Now, the logger itself requires power, and it's connected to the PC using a serial adapter or a USB to serial interface for initial configuration on your computer. After that, it can be disconnected from the computer and later connected to download the data, or you can optionally have it remain connected to the PC at all times to get the most up-to-date readings downloaded and stored. So let's talk a little about the converters and alarms and how they're addressed by the logger. In terms of converters, each converter is programmed with an ID number from 1 to 15. With alarms, only the ELO42 alarm and relay unit can be programmed with an ID number. This can be from 1 to 31. However, we would advise that you use the addresses 16 to 31 for alarms. Other alarms like the EL006 and the EL018 do not have addresses. No two units, be it an alarm or a converter, can have the same ID number. Every converter or alarm should have a unique ID. The ID address of the converter or alarm can be changed by going into the environment software under the utilities section. Now, in terms of the converters or alarms that you can have on an environment system, it has the capability of having up to 15 converters or alarms connected per logger. This will depend upon the type of converter or alarm that's used and on the converter or network cable length. Generally speaking, 10 converters or alarms is easily achievable. For more converters or alarms, you can just use multiple loggers. Each will be connected to the PC using a serial or a serial adapter, and each logger will have its own set of converters or alarms. All will appear in one instance of the software. So let's focus on the data logger, which is at the heart of every environment system. The EL005 is the current data logger. Previously there was the EL008 data logger, so I'll put a picture of that. But this has been obsolete for over 10 years now. Now, the key difference between the two loggers is that the EL008 had a display and buttons, whilst the EL005 doesn't. Storage on the EL008 was 15,000 readings, where the EL005 has 250,000 readings. The EL008 used 4 AA batteries in case of mains failure, whilst the EL005 uses a rechargeable NIMH battery. However, most of what we'll be covering in the troubleshooting series of videos will apply to both units. So from this point on, I'll focus on the EL005 data logger, as this is the current logger and the vast majority of units out there are EL005s. So let's break it down into parts. The EL005 data logger has an internal battery backup. At the time of doing this video, it's a 4.8 volt 2000 milliamp rechargeable NIM-H battery. Now this hasn't been the case in the past, but most likely if you bought the logger in the last 6 years or so, it would have been. Now when the loggers were first introduced, they used to use a 600 milliamp rechargeable battery. In any case, the battery has a limited life and will diminish over the years. So if your logger is a few years old, it might be worth looking into getting another battery, and we can help you with that. Now this begs the question, how long will the data logger last on a battery backup? Well, this depends on a number of factors. How many converters are connected to your logger, as these are powered by the data logger from the converter cable. So obviously the more converters you have, the more current it will consume. What sampling interval are you using? So for example, sampling at 1 minute intervals will use more battery than say every 30 minutes. How long is or are your converter cables that connect your converters and or alarms? So are you using the standard 5 meter converter cable that came supplied with your units, or have you made a 200 meter long cable? Do you have any sensors that are being powered by the EnviroMon system? So say for example you're using the ELO37 general purpose converter with a third-party sensor being monitored. The EnviroMon system could be used to power the sensor if it meets the sensor's power specification. Or you could use an external power supply, which is what we would normally recommend. If you are using the EnviroMon system to power the sensor, it will obviously consume current, and different sensors have different current requirements. So, to give you a rough idea, a fully charged battery that's in good condition with one converter connected and a 5 meter converter cable could last over 24 hours. Now, if you had more converters or a larger load in the system, it could last hours or even less. Now, it's worth noting to fully charge a drained battery, it will need a full day of charging as a logger trickle charges the battery. An important point to note is that when you connect the logger to the PC to download the data, the downloading process could consume a bit more current. So say for example you had a logger in a remote location and you took it to the PC to download the data without the power supply. If the battery was low for whatever reason, a situation may arise where the downloading process drains the battery before the data is downloaded. So it's always recommended to connect the power supply to the logger when downloading the data. The EL005 data logger can store up to 250,000 readings, which is shared across all the channels. So if, for example, you had 2 temperatures that you're monitoring, this would be shared across them. So you'd have 125,000 readings for each channel. And if you had 10 channels, it would be 25,000 readings. Now, along with the number of channels that you're measuring, the sampling interval will also dictate how long you can store your data for. So if, for example, we had 10 sensors at 1 minute sampling intervals, this would be 25,000 readings across each of the 10 sensors. So this would be 25,000 minutes of storage. And if we divide this by 60, this would give us 417 hours approximately. And if we divide it by 24, this would give us a total of just over 17 days. Now let's say the sampling interval was every 10 minutes instead of every minute. The total storage would be over 170 days. An important point to note is that the storage used on the EL005 data logger is volatile. This means when there is no power to the logger, the data on it will be lost. So the battery backup will keep the logger running for a while, but once the battery backup is depleted, your data on the logger will be lost. So the next thing we'll talk about is the connection interface between the logger, converter and alarm units. Each of these devices has 2 ports, which allows you to daisy chain them together with the logger. Each of these ports provides power and communication, so you only need to power the logger and your converters will be powered by the logger from the converter cable. With the logger, you have the option of using one or both ports to connect your converter and optionally alarm units. This will depend on the geography of your location. However, if you were to use both ports on the logger to connect your converters or alarms, it is not recommended to create a loop, as this could introduce problems due to reflections from mismatching impedances. So if you were to use both ports on the logger, leave them as two separate paths. There are 4 wires used: ground, power and 2 data lines. The connector used to connect the logger is an FCC 6P4C connector. This is a 6-position and 4-conductor connection, which basically means that out of 6 positions available, only 4 conductors are used. These are the middle 4. Now this is important as some of the environment sensors use a slightly different connection. For example, the ELO15 temperature sensor and the ELO30 temperature and humidity sensor use a 4P4C connector, which is a 4-position and 4-conductor connector. As you can see, this is a narrower connection than the one used for the EnviroMon network. So if you're making your own cables, make sure you use the correct connectors, as the 4P4C connector will fit into the port but will be loose. Now the environment system can be powered by either a 12 volts DC unregulated power supply, or you can use a 14 to 18 volts DC regulated power supply. Now they used to be provided with a 12 volts unregulated power supply, which used to give approximately 17 volts when plugged into the logger, but we now provide them with a 15 volts DC regulated power supply. And the DC plug that's used has an inner diameter of 1.3 millimeters. Now the logger has a reset pin situated between the serial port and the LED. As you can see, there's a small hole, and you can access this using something like a paper clip. So if I place this in there for a couple of seconds, you see the state is changing from flashing to solid, and if I place it in again for a couple of seconds, it goes from solid to flashing. Now this is something that you'd use if the logger gets into a frozen state, or if you want to reprogram the firmware on the logger. It's not something that you do often, however we will be covering it in another video. So this concludes the first video in the EnviroMon Troubleshooting series. The next few videos will go into some of the problems that you might encounter and how to troubleshoot them. So thank you for watching, and make sure you check them out.